Hello, welcome back to the second part of the episode 6 on the UC4H ECs and OreoLEDs. And in the second part we are going to talk about the EC telemetry. And I think that this is really a very important and useful feature of using UAVCAN ECs. Now, as an introduction, let me tell you what kind of information this gives you. So here is the UAVCAN EC status message, which is used to transport the information from the EC to the flight controller, and it has a number of fields, among which are the voltage, the current, the temperature and the RPM. So that's the information which you are getting for each EC. And there's one note to make about the RPM. The D-shot EC, being it the KISS or Biel-Healy, gives you the electrical RPM in their telemetry packet. Now, the electrical RPM is not what you usually want to know. Usually you want to know the mechanical RPM, that is the actual rotation of your propeller or motor. And these two quantities are linked by the motor pole pairs, by the number of motor pole pairs. And in order to get this number right, what you have to do is you have to go to the node configuration, and here are the parameters for one of the EC nodes, and what you have to do is to set this number for this motor pole pairs to the correct number. So in the previous video I was telling you that it's very often it's 7, but it needs to be set to the correct number. There's also a second parameter in here which is related to the EC telemetry, namely this EC status rate, which is set to 200 here, which means 200 milliseconds, which means 5 Hertz. And so our telemetry packets are sent out at a rate of 5 Hertz. So we want to use it also in our flight controller, and there are three ways in which this information is used. Namely, the data is translated into a MAVLink package and sent out to the ground control station. This data is packed into your DataFlash so that you can analyze it after your flight. And then this data is also fed into a battery monitor of a particular type. So I've given it the type number 84. Now, in order to use this MAVLink and the DataFlash, you don't have to do anything in the configuration. For this BattMonitor, you need to configure it. So therefore we go into Mission Planner. So I will connect now the battery and then connect to Mission Planner. So we are now connected. So we go into the parameters, and you might recall that in order to use the power brick, we have enabled this BattMonitor number 1 here by choosing the type 83. Now, in order to use the BattMonitor, which is related to the EC telemetry, we can use the second battery monitor, and the type value which you have to enter here is 84. So you enter 84, you write, and then you have to reboot the system, and then it's enabled. So I'm going to reboot now. So I have rebooted and connected to Mission Planner again. And now we can look again at the parameters, and you see that we have now this battery monitor 2. And if we unfold it, we get all the parameters related to that. And here's this parameter 84. And usually you don't really have to do anything here. I mean, you could set the battery capacity and the low charge and so on and so forth if you wanted to use it for fail-safe or something like this. But I usually don't do nothing. Okay, so the battery monitor 2 is now also enabled. And let me now show you what you can see in the Mission Planner. So we can go here to the status section and look for the EC data, and it's here. So you find now this entries EC 1 volt, and you see that the battery is connected, so it reads a voltage of 11.56, and here for comparison, this is the voltage read by the power brick. So there's obviously a consistency here, and well, the other values, they are fluctuating at small values right now. So what I can do now is that I arm the copter. So it will arm, and then I can just move the stick around, so you can see that these values were indeed changing, and you also can hear it. Now we're at the high rotation frequency, you see the RPM values going up and down. So that's the information you can get in Mission Planner. I must admit that it's not totally clear to me what great use this has. I mean, one can control it, one can see it, but I'm not totally sure what I would use that for. What I find more interesting is to use the data log. And here, let me open one. I just take this one here. So that's this. So just to show you that this is really a flight. Oops, this was the wrong button. I wanted to show you this. So there had been a real, it's a test flight, but it's a situation where this thing was flying around. And when you look now into this parameters here, which are available, you find this entries EC1, EC2, EC3, EC4. So these are your telemetry packets. And so we can unfold that for a moment to see what, so that you can see what's in there. And you find all these values as RPM, voltage, current, and the temperature. And there's also now the battery monitor number 2. I will come to that in a second. So just let's see how this looks like. So here we can look at the RPM, for example. So I click them all like this. So we have now all the RPM values. What I can note, or what one can note, that for my copter, there's obviously a systematic discrepancy between the pairs of motors. So I'm not totally sure what the reason for that is. So this would be the motor 1 and 3, and this would be the motor 2 and 4. So this would be the one-way rotating propellers, and this would be the other-way rotating propellers. So not sure if this is due to the different propellers or that they are counterclockwise and clockwise. I don't know, but that's how it is. We also can see this pattern when we look at the current, for example. So that's now the current which the ECs were consuming. So you can see also that. And we could look at the temperature and voltage right now. So I don't want to do that. So you can believe, let's just show the voltage. So it's on all the motors, it's roughly the same voltage. Okay, so that's this feedback information. And now this information is also fed into the battery monitor 2 in order to estimate an improved voltage. So that's this voltage. So if I take again one voltage of 1 EC, when you see that it's more noisy, so there's obviously some averaging going on. And you also can compare that now with the voltage from your power brick. So I click this one here, and then, so that's the green line now. So you can see that the voltage from the EC telemetry battery monitor is of course much more noisy, but it's not too bad actually. So I kind of like that. Now we can do the same thing for the current. So that's the current as measured by the power brick, and that's the current as measured by the EC telemetry unit. So you can see I've clicked this and clicked this here, and they are actually relatively similar. So it's not like that this EC telemetry gives totally nonsense value. It's pretty consistent actually. So, but there's also a consistent offset. So this means that the current through the motors is not all the power consumption. Now what's also interesting to look at the charges, consumed charges. So the red one is what the power brick calculated, the green one is what this EC telemetry calculated. And one thing you can note, I mean, it's of course off because the ECs do not see all the power consumed, but it's not too bad. I mean, if you just would add to the current a constant value, you probably would get this in a relatively close agreement. So which means that if one wanted to, one doesn't need a power brick, one actually could use this EC telemetry as a battery monitor. So I was actually surprised how well this potentially could work. Okay, So this is the battery monitor features. So and these are now, I've just shown you now with 3 features which you can get with that. And with that I want to finish with discussing very briefly what use all this could have. And one idea was to trying to measure the nonlinear relationship between the RPM of the propellers and motors and the applied PWM value. And this nonlinearity is accounted for in ArduPilot to linearize the PID controllers, and it said that this improves quite significantly the behavior. So one could attempt to measure the relevant parameters here. I'm not sure how well this is really working or how important all this is, but now that's one possible idea. Another idea was or is to use the actually measured RPM of the motors to adjust notch filters dynamically in order to filter out the harmonics or the signals or the noises which are coming from the rotation of the motors. And at least in this post here it said that this is being done in beta flight, very recently has been done, and that the first results seem to be very exciting. I'm not sure if this can be done with UAVCAN, because you remember before that our telemetry is about 5 Hertz now. You might push it maybe up to 50 Hertz, but this would be already a bit stretching, I would think, and which I think might not be sufficient to do such dynamic notch filters. However, when this dual weight D-shot is coming and is established, then one actually might improve the situation also for UAVCAN nodes. And this could then be a real potential application, but at the moment it's difficult to judge. There might be some other ideas of how to use that. In my opinion, the most important use case currently is really just to control the health of your system. And I must say I indeed had some cases where in hindsight, if I would have looked more carefully into this data and in particular would have taken it seriously what I have seen in this telemetry data, I could have detected some issues I had with a motor much earlier and much simpler. So this issue with the motor I had was in the data, but I didn't take it seriously. So I think that this post-analysis of this data actually can be a very helpful tool to diagnose the health of your whole system. And I think that's an important thing, I think, and that's currently doable and possible. Okay, with that I want to finish and want to thank you for your attention and see you in the next episode.